you don't quite know what they are. He's processing this and he's feeding this data, how many events we're getting for the VLP, these are the fluid flow events, and also the micro-earthquake events. So now we're getting systems in place to make it very easy for the parish and OEP to be able to digest the seismic information into what it means. This is up and running now, and we talk to Dr. Horton literally every day. So we've got some really good, in addition to Dr. Pettit, we've got Dr. Horton is on board and fully engaged. And at this point, Dr. Pettit will talk about Oxy 1.
Hello again. I'm actually going to talk a little bit about Oxy 3 and show you some the first modelling results that we've produced. When I say modelling, what that is it's a technique called geomechanical modelling that uses very sophisticated computer programs to try to understand and simulate how rocks behave. And in this case, the rocks I'm really referring to are sedimentary layers outside of the salt dome. So this is the Napoleonville salt dome. Here's Oxy 3 cavern, and here's Oxy 1. And this is down to about 5,500 feet at the base of Oxy 3. What we believe happened in this case is that Oxy 3 had a sidewall collapse, and that collapse propagated up to the surface. So when we build these numerical models, they take about 10 days to run on like the latest computer systems. So they're very sophisticated. This is a very large volume. What we do is we put all of this geometry into that computer model and all of the rock properties that we have available to us for both the salt and the sedimentary, and then we watch how the rock just naturally behaves. The computer program is designed to really have all of the kind of physical response that a rock has, and you're able to kind of simulate that behavior through time. So if we go on to the next slide, hopefully this works. We have a movie. I'm going to show you Here we go. So this is the Napoleonville salt dome that you're looking at. This view is actually southeast. And actually this is the graphic that was on the screen earlier on for quite a while, probably before on Gary's title slide. The ground surface is up here, and the cavern is actually buried within the salt dome here. And what happens is, this is kind of repeating through the cycle. What happens is the sidewall of the salt of the cavern collapses in, and in that collapse, what it does is it removes volume from the rock immediately adjacent to the cavern, and that rock breaks up, and then that creates a chain reaction, and that chain reaction creates this what we're calling a disturbed rock zone that propagates all the way up to the surface. And as it reaches the surface, what it does is it then creates a sinkhole. So the sinkhole is really the surface expression of this highly damaged rock volume that reaches the surface. As it goes up, what we believe is happening here, and this is what's key to something that Gary mentioned earlier on, is the 3D seismic. 3D seismic is going to tell us whereabouts the gas reservoirs that this disturbed rock zone has passed through. And those reservoirs are really producing the gas that's coming through to the surface. So once we have the 3D seismic information, we'll be able to combine that with this model and work from there to really understand the gas problem some more. Okay. So I'm just going to talk to you a bit about the Oxy 1 stability. First of all, Texas Brine performed this BSP earlier on in the year, in January, and they found that Oxy 1 is nearer to the edge of salt than what was previously believed. And the situation that we're in, really, I think, is is the analogy that Gary gave a little while ago at the start of the hurricane season. We know there's a danger there, and we know that we need to watch it. So we're putting in all the instrumentation that we need to be able to really accurately look at that behaviour, at what's actually happening around us. So what we've done, the first thing we've done is taken what we know about the cavern and looked to try to predict what the sinkhole would look like if it were to fail. I'm not saying that it will, I'm saying that if it was, what is that sinkhole going to look like? Because we need that to make plans, as the governor was saying today. And the initial sinkhole analysis suggests that if it did happen, the sinkhole diameter is about 460 feet, and the sinkhole depth estimation is about 80 feet. And we're fairly confident with this because we've done the same analysis on the current sinkhole, and we're about right. The Oxy 1 cavern has also been looked at by 4 cavern experts that are contracted to DNR, and there is no indication of instability at present from any of the data. So there's no evidence whatsoever that Oxy 1 cavern is unstable. Most of the seismic events that we're seeing, we now believe are around Oxy 3. So the continuing collapse of that cavern. The best thing to do with Oxy 1 is to maintain pressure in that cavern and to monitor the microseismic activity, to watch it, to observe what's going on. And that's what we're going to be doing. The other thing that's really important is that movie that I showed you, what we believe happened there with that propagation of disturbed rock zone from 5,500 feet up to the surface. We believe that took many, many months, maybe a year or even longer. So we're going to have, if anything was to happen to Oxy 1, we're going to have many, many months. Now we have the instrumentation in place. Many, many months to kind of prepare. We're going to be able to see it happening, and we're going to be able to respond appropriately.
We got to know about it before it started?
I'll take questions at the end, if you don't mind.
I don't remember that, I do have an answer for you.
Do you want to answer it? Do you want to answer it now?
Yeah, the answer was, are we doing anything to stop it from happening in the first place?
You got those months and months ahead about it. You got to know anything about it?
I'm talking about Oxy 3.
Not on Oxy 3. No. Oxy 3, we didn't have the instrumentation in place.
Talking about Oxy 1.
Yeah, nothing has happened to Oxy 1. Oxy 1, as far as all the evidence that we have, Oxy 1 is completely dead. So just to put that on a map, just to give you some kind of idea of if it happened, if something happened to Oxy 1, and as I was saying, we would know about it now, then this is really the resulting disturbance on the surface. So this is this disturbed rock zone that we are talking about with Oxy 3, that we've been able to model very effectively, and this is the sinkhole that's there, that's on top of this disturbed rock zone. In the case of Oxy 1, what we believe would happen, the most likely thing that would happen, if it were to, is that the roof would come in. And in that case, the sinkhole would be formed immediately above the Oxy 1 cavern, most likely. So this is really what we think is the most likely scenario, the sinkhole being directly above Oxy 1 and about this dimension. And really it feeds back to what Gary was saying earlier on, that the cavern is much, much smaller than Oxy 3. So you can see the circles are much, much smaller. The blue circle is really the worst, what we think right now is the worst case scenario. And that's still about 600 feet away from the highway.
Where's the north and south burn?
Sorry?
The north and south burn, where are they at in relation?
I believe they go around the sinkhole like this.
Okay, what about the north-south? Where does your outer, the blue circle, does it go past the berm?
Yeah.
Yes. Yeah. But remember, as I say, this is going to happen over, if it were to happen, it would happen over many, many months. So we would have a long, long time to really prepare for that event to happen on the surface, for any disturbance on the surface. Yes, sir.
How would you prepare for that?
We would have to consider that when that started to happen. And there is a contingency plan in place that the Governor's Office has released for looking at the kind of, I don't, if you've read it, it's a green, yellow, red alert level for Oxy 1, specifically for Oxy 1. And right now we are on green and we're doing everything in the green alert level that's required. And yeah, you can go, it was, I believe, in the newspapers and actually on the Governor website, you can find the press release. Yeah, and as I say, we're watching, so we'll be able to see anything that happens. So, and really I wanted to really emphasize this. This is long-term.
Back up one slide. Deborah.
I'll get that lolly back.
Would you point out the seismic station in relation to Oxy 1 so people understand the seismic array?
Right, the seismic array has been designed specifically to monitor this volume. So they're in effectively a ring around the Texas brine area. So and these numbers that are on this slide refer to the numbers that you see on the helicopters if you go to the website that's run by the University of Memphis. So there's station 11, 12, 13, 14, 15, and actually 16's hidden behind this legend. Then there's also an array in this well. It's an array of geophones, 3 geophones in the well to get even more sensitivity. And these are positioned down to 450-foot depth in this well. We have another new well that's being instrumented very shortly up here, where another 2 sensors are going to go in. And we're also installing a microseismic system which is going to produce much more sensitive information and with much better location accuracy. We're going to be able to see events with depth with much more accuracy, and that's really key. We're going to be able to see events accurately around the caverns. So, long-term seismic monitoring. We've now put this instrumentation in place, and we have it there primarily because we're going to be able to observe what's going on. We're going to be able to warn you and stakeholders in this project what's actually happening underground. So we now have this capacity to observe rock disturbance around the caverns and the disturbed rock zone. We can observe any progressive build-up of activity that leads to a sinkhole burp, and we're now doing this in real time, and you would have seen in the newspapers that we're processing the data and we raise alert levels so that people don't go on the sinkhole. We're now currently at a level 2, which is that people don't go on the sinkhole. So we're able to provide this advice on this daily safety level for any of the workers nearby. And we can also observe the progressive disturbance of that rock. And we can combine that with our numerical models. So our models provide a simulation of what's going on in the rock. We can take all of this seismic data that we're recording and we can use that to make sure that our models are behaving correctly and that we're going to be able to simulate what's happening correctly. We can use all of this information with our models to assess risk of collapse in Oxy 1 and elsewhere, and formulate, as the gentleman asked, further emergency response plans and more monitoring if we need to. As I say, this process, if anything happened to Oxy 1, would be very slow. So we can develop response